Welcome to the second video of Garmin's King Air Autothrottle series. We're going to discuss automation management more broadly and consider how the autothrottle fits into our automation strategy. Now, pay attention. The autothrottle can be a great tool to manage workload, but mismanagement can have serious consequences. Asiana 214 and Turkish 1952 are prime examples. Applying the strategies in this video will help keep you ahead of your aircraft's flight path and the automation. Our recommendations are sourced from best industry practices and FAA guidance, such as Advisory Circular 120-123 and Airbus's Operations Golden Rules and Optimum Use of Automation. Consider those resources for a more in-depth discussion of these topics. Let's first talk about flight path management. Advisory Circular 120-123 defines flight path as the lateral, longitudinal, and vertical trajectory and energy state of the aircraft, and it defines flight path management as the planning, execution, and assurance of the guidance and control of aircraft trajectory and energy. Automation is a great tool to assist you in managing the aircraft's flight path. It gives you more time and attention for other flight-critical tasks, such as modifying the flight plan, running checklists, scanning for traffic, and briefing a procedure. But when the automation does not work as you expect it to, you could fixate and lose situational awareness of where the airplane is and where it's going. Remember, if the automation is taking you off your desired flight path, take control and get it back on track. Hand flying is always an option. Let's take a look at our principles of automation and see how they assist us with flight path management, starting with an accurate mental model. An accurate mental model will prevent you from asking the classic automation question, "What's it doing now?" To know what it's doing now and what it will do next requires a full and deep understanding of the system, the mode behavior, and the pairing of autothrottle modes with the vertical AFCS modes. You should always be one step ahead of the autothrottle and anticipate its next action. During the flight, you should pay attention to how the autothrottle responds to changes in the vertical AFCS mode and compare the actual state of the airplane to what you expect. If the autothrottle mode transitions and moves the power levers as you expect, then you have an accurate mental model of the automation. If the autothrottle does not respond as you expect, your mental model may be incomplete. It may be responding exactly as designed, but you don't fully understand the logic behind the response. You may have missed a step in programming the automation, such as selecting the correct speed source. Or there may be another system failure that is preventing the automation from properly responding, as was the case in Turkish 1952. Regardless, if the autothrottle does not respond how you expect, it's time to take deliberate and decisive action to return the aircraft state to where you want it.
Autothrottle.
Correct the aircraft state first, then troubleshoot and determine the cause of the deviation. After developing an accurate mental model, you must monitor the autothrottle to ensure it responds as you expect it to. The best ways to monitor the autothrottle utilize 3 of our 5 senses: sight, sound, and touch. We're still working on strategies to incorporate smell and taste. Remember, these are strategies you already employ for your autopilot. We're just adding a couple more things to watch, listen, and feel for. You're watching the AFCS status bar and the autothrottle mode enunciation. You're listening for autopilot tones and autothrottle disconnect alerts.
Autothrottle.
You're following the yoke and the throttles with your fingertips. It's especially critical to monitor the flight path closely during changes in the flight path, when making changes to the flight plan, after selecting a new mode, or after a period of distraction. Mode awareness goes hand in hand with effective monitoring. Good mode awareness knows what the autothrottle is doing and what it's going to do. It's knowing what's happening and what's coming. A great strategy is to call out all mode changes as they happen. When you verbalize the mode changes, it keeps you in sync with the aircraft. You anticipate the change and verify it as it's happening. Now, say you're monitoring the autothrottle and using your mode awareness to see it go into a mode that does not match your mental model. Remember, you're the PIC. Take action to either disengage or correct the mode. There may be times when the time to intervene is obvious. For example, if a fault occurs and the autothrottle automatically disconnects. Another example would be if the flight path diverges from what you expect. Keep in mind, we can't list every possible failure here. Undesired automation states may be subtle. Always follow the principles of automation management and hand fly if necessary. And one last note on intervention. Most of the time, when you fly, you'll be using the automation. Don't let the automation degrade your hand flying skills, which is one of the best parts of flying. Now that we've discussed our core principles of automation, let's begin building our mental model of the Garmin Autothrottle. The next video will cover the components that make up the Autothrottle system.